Alright, you guys, I just did this video and it didn't stick. I tried to save it and it got lost somewhere when I was saving it. So I'm going to walk you through transformations of a graph. We're going to try to get through the first 2 pages, so I'm going to start right in. 1.3 is transformations of a graph, and we move things, we stretch things, we flip things. Transformation, we have reflections and dilations that we're going to end up doing with these letters down here, right, that are part of this every function, and they're called parameters. So the parameters we're dealing with are A, B, H, and K. And before we do anything, I'm going to point out that B and H are within the function. This is the function sign, right? So if this was a quadratic, which we're going to be dealing with, your function would be x squared, and B and H would be inside with the x, these parentheses, getting squared. A and K would be outside. So they're going to do some sort of transformation when we change B, H, A, and K. Those parameters are going to have an effect that we're going to learn and see in practice. Sorry, my voice is a little off today. Anyway, parent function, quadratic. Function of x equals x squared. We're going to learn the parent function. We're going to do this quite often this year. X squared is called a parabola. All right, this quadratic function creates a graph called a parabola, which you can see is a U-shaped graph. It's got a vertex at 0, 0, which means its axis of symmetry is on the y-axis, which is x equals 0. Its domain never stops going left, never stops going right, negative infinity to infinity. The range, the bottom is 0, goes up to infinity. And I just listed some reference points, so they were listed in the notes that I've given you. Negative 1, 1, right here, 0, 0, 1, 1. All right, we're going to investigate. If you got a calculator, that would be wonderful. All right, I'm going to show you my calculator here. I changed my window, as you should. This is a decent window to do most of our investigations. Negative 10, 10, 1, negative 10, 10, 1. And I went in and I put x squared right there, which if I graph, gives me my graph of the parabola. All right. So we've got this. We've got k equals 4 that we're going to change. So we're going to start dealing with the one outside here. Okay. Now, if I look, notice the function takes place and then you add k, because k happens outside the function. So if I was going to make k 4, it would say f of x plus 4. Alright. Now, if I translated that or transformed that into the function being x squared, its g of x is x squared plus 4. Alright. Now, here's what we get, right? We get a transform function that we can look at. So I'm going to go here and I'm going to write it with a k of 4. So I have x squared plus 4. If I graph that, we can see what the k being 4 does. The k moves us up. So when I made k equal to 4 plus 4, it took the entire graph and translated it up 4. Well, as you can guess, what if I make it negative 4? Well, changing my k to a negative 4, so I go to y equals. I'm a little distracted. There's a puppy downstairs, and he is nibbling on my son, and my son is upset because the puppy has sharp little teeth. Sorry. And when I say minus 4, instead of moving up 4, it moved down 4. So it looks like the k parameter, if I say everything right, the one that is outside the function, moves me up and down. Alright? If it was 4, it went up 4. If it was down, it went down 4. So we're going to switch and look at the h parameter. So here we go. Now this one says let's let h be 2. So when I plug in 2, notice that it's minus h. So when I plug in 2, it turns into minus 2 in the equation that we write. So if I said g of x equals x minus 2 squared, right, replacing function notation over here with the actual function of a quadratic equation, right? If we graph it, we'll see what happens. So I go in here, and I'm going to graph that a little differently. Alright, I'm going to say parentheses, x minus 2 in parentheses squared, and hopefully delete all that other stuff outside there. There we go. And these two as well. Delete, 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 delete. And if we graph that, we're going to see that this graph, what did I do? Oh, I used a minus instead of a negative. Or negative instead of a minus. There's my minus sign. And I go in there and I see it has moved 2 to the right. So there it is. That means when I plug in a 2, even though it's minus 2, it's a little bit counterintuitive. It moves right instead. Right? And you can imagine if I plug in a negative 2, this says now plug in a negative 2. Well, if I plug in a negative 2, right, a negative 2, it's really like plugging in f of x plus 2 squared. So if I did that here, and I changed this minus to a plus, and graphed it, we would see that now, with that plus sign, it moves left. So the h value seems to be very counterintuitive as opposed to the k value. Right? Oop, knocked my camera off a little bit. There we go. So here's what we noticed. We noticed that if I move vertical, it has to do with a k, and horizontal has to do with the h. We notice the k is outside the function, out there, and the h is inside the function. Being inside makes the h, I'm coming over here on the right side, change with my kx coordinate, right? And my k changes my y coordinate because the function's already taken place. Right? Now, making a positive k moves me up, a negative k moves me down. That feels right. This might feel a little weird. Right? Having a plus h in there moves me left, and having a negative h in there moves me right. And this is a little bit weird. So if I had this, if I had x plus 2, that would be 2 left. X minus 2 would be 2 right. Just to kind of throw out here with numbers. And think the opposite right here. Think it's the opposite of what you would think when you're doing the h value. Down here there's 4 examples, and I'm just going to point and save this pretty quick so it doesn't take too long. There's my h. My h is actually negative 2, but it looks like a plus 2 there. That's 2 left. Negative 1k is 1 down. No h, but this 5k moves me 5 up. Alright. My h is actually 7, but there's a minus h. Alright. That's because there's a negative in the function, so that makes my h 7. And, you know, I wrote this wrong, so it's a good thing I did this. This guy right here isn't 7 down, it is 7 to the right. Alright. Maybe my computer was smarter than me and stopped my mistake. This is 3 right and 9 up. And we're going to stop there. And that's going to be our h and k for right now. I hope I can save this one. Talk to you guys soon.